Hello everyone and welcome to Module 2, Discovering Wi-Fi Essentials. My name is Chris Avance. I am the Principal Instructor here at Wi-Fi Training. I am a CCIE Wireless, a CWNE, and most importantly, I'm absolutely certain I can help you with understanding the essentials of wireless networking. So let's begin. Alright, first question we got to get out of the bat. What is Wi-Fi? Well, Wi-Fi is the number one network access method today. Enterprise, at home, companies of all sizes use it. It's used in airplanes, it's used in coffee shops, and everything in between. It's also another name for a suite of protocols in the IEEE 802.11 working group. Technically, the word Wi-Fi is a made-up word. It doesn't necessarily mean anything, but it was made up by the Wi-Fi Alliance to describe this suite of protocols in the IEEE working group. See, there's several protocols under this IEEE 802.11 standard. In fact, there's over 40 sub-protocols in the IEEE 802.11 series of protocols. So Wi-Fi just sounds cooler. It's easier to say than naming off every protocol and standard that's under that IEEE working group. Now, Wi-Fi does use several common bands from the electromagnetic spectrum, commonly the 2.4 gigahertz, as well as the 5 gigahertz range. You learned more about that in Module 1 of this course. It is the choice protocol for indoor wireless networks. It scales better. You know, I'm constantly asked, Chris, why don't we use cellular everywhere? Well, that's a good question, but most cellular plans to date are pay-as-you-go services or pay for download. Cellular doesn't necessarily work as well indoors as wireless does. With Wi-Fi, we own the network. We can deploy it anywhere. And essentially, we can scale as we need to, and we can provide a seamless roaming experience, as well as have people on our network, which is becoming a much more important fact for wireless network operators. You know, used to it was just we need to have people connected, but now we understand that we can get a lot of benefits by understanding what users' habits are while they're on our network, essentially how they interact with our stores or our locations. So there's a lot of benefits by having wireless and Wi-Fi in particular, but Wi-Fi really is just one of many protocols we can use to connect to the internet or a network wirelessly. And we're going to talk about several, but we want to make the distinction whenever we're talking about 802.11 based wireless, we want to refer to that as Wi-Fi or 802.11 and not so much just say wireless, because there are several wireless technologies as you're going to learn about as we go forward. Now, Wi-Fi and the scale of those technologies, it's cost effective. I think I've already mentioned that. It's scalable, it's reliable, and there's a lot of advanced applications such as those retail environments, connected mobile experiences, and the things that I just previously mentioned. Now, one important thing I do want to point out before we move on to the next slide is there are products specifically designed for home and for the enterprise. There's a pretty big distinction we need to make with that, because ultimately with our wireless networks, we're trying to provide a good end user experience. And essentially the products we choose has a lot to do with that. It also has a lot to do with capabilities, because products designed for the home are not necessarily going to have the same capabilities as those designed for the enterprise, especially whenever it comes down to security and compliance issues and things like that. We want to be using enterprise grade products for those enterprise environments. That's what it's designed for. The other thing I wanted to point out here with this slide is wireless is Wi-Fi is half duplex medium. So a station could send or receive, but not at the same time. At least with the majority of protocols out there, there is some simultaneous sending and receiving with some later wireless technologies with MIMO. We're not going to talk about those yet. So for now, it's completely half duplex, and that's the way it really is for the overwhelming majority of wireless communications today. There are several architectures we need to understand whenever it comes to wireless. Now, again, whenever we're talking about wireless architectures, now that we've made that distinction between Wi-Fi and wireless, we're talking about a number of architectures. Could be any technology, necessarily if we say wireless. Okay, so but there are several architectures, and these really refer to the geography of coverage for that wireless technology. For example, WPAN is wireless networks that really can provide connectivity within 30 feet of a person. So it's a personal area network, and there's one technology that really makes that up, Bluetooth. We're going to talk more about that in a moment. We have the wireless LAN. Now, wireless LANs can extend to numbers of buildings, numbers of locations, outdoor, all that kind of fun stuff. But essentially, we're talking again about a particular type of architecture and technologies we would use in the wireless LAN, predominantly Wi-Fi. Now, wireless MAN, we've got a bigger geographical area to cover, so we might be using other technologies for that wireless MAN. We're going to talk more about that in a second. And wireless WAN is the same thing. It's an even bigger geography to cover, so we're going to be using technologies other than Wi-Fi and 802.11 to cover those areas. So let's look at what each one of these architectures would require as far as wireless technologies. First of all, WPAN. WPAN is this personal area network. Bluetooth is pretty much the de facto protocol that came out for this WPAN. It really defines the WPAN architecture, okay? So, and it describes wireless networks with a reach of about 10 meters or 30 feet. And it was designed to replace those pesky cables, right? So there are some other WPAN technologies, or I kind of like to throw them in there with the WPAN technologies. Some of them have a little bit better coverage area than the 30 feet. So to speak, but wireless USB is another WPAN technology. Zigbee is one of those that covers a little bit further than 30 feet. But you have all these new Internet of Things and Internet of Everything technologies that are coming out. You're going to see a lot of other protocols other than Wi-Fi being used, and for different purposes, right? So, for example, Zigbee is used with home mesh wireless networks and home automation series. Whenever I moved in this new house a few years ago, I put in a home alarm system, and every window essentially has a sensor, and if somebody opens a window, then it would set off the alarm. Now, those sensors are battery powered. They're not connected to a wired network, and they last for years and years without having to replace those batteries, which is pretty cool. But essentially, those devices aren't actively communicating all the time. They're not downloading files or anything like that. They essentially just send a quick burst of energy across the wireless network, across the Zigbee wireless network, that tells you whenever the window sill has been opened. Other than that, it pretty much just sits there and sends out a little beep every now and then to let the control panel know that it's active. But other than that, it doesn't talk a lot, and therefore doesn't require a lot of battery, right? So each of these protocols has a different purpose and different use for them, and Wi-Fi is just the predominant one we use most of all today to access the network or internet. All right. So let's take a look at this WLAN. That's what we're talking about. With wireless LANs, we've got coverage from 100 meters, about 328 feet, with a single AP, or we can scale that by using multiple APs and essentially overlapping some of the cells, but on different channels. And we'll talk about that channel usage and all that kind of stuff later, but essentially, we want to blanket the wireless environment. We want to blanket the area with coverage with Wi-Fi so that users can seamlessly roam anywhere in a building. And again, Wi-Fi can scale to thousands and thousands of APs, and even outdoor wireless and citywide mesh, which we'll talk about in a moment. But essentially, we can support real-time applications. We can get you very good data rates. There is theoretical physical speeds now of well over gigabit speeds for Wi-Fi. Now, that may not be realistic in an enterprise today, which, again, that's another thing we'll kind of mention on later. But the speeds are approaching that of wired networks, and most devices nowadays are not even including, wired adapters. This is pretty much the number one network access method now. With our smart devices, all that kind of stuff, it is awesome. That's why we're here, and there's no better time to be learning this technology than right now. Of course, if it's designed properly, we can support voice video streaming and indoor and outdoor applications. For the wireless MAN, metropolitan area network, wireless deployment essentially citywide or metro area. And essentially this is what we call for those outdoor mesh APs. 1500 series, for example, by Cisco would fit in that category. And it's an access point. It supports the same 802.11 protocols as your indoor access points, but there's some key differences. Typically, these APs would mount on utility poles or traffic lights, so they have special power adapters and power requirements to power these devices. They may also have special weather-rated containers that they're in, or chassis that they're in. They may also have special antennas that are used for communicating outdoors to give them a little bit better coverage and blanket the area a little bit better. Now, Wi-Fi is used in these metropolitan area networks as a technology. You may also see cellular being used as a complementary technology, or cellular being used in areas where we don't have these mesh APs located. And then also we may call on another technology, WiMAX, which is not Wi-Fi, but it is a wireless technology where we can get much greater distances with this technology, but there are different limitations for each of these than there are, of course, for Wi-Fi. These are just some of the other technologies that fit within the architecture for the metropolitan area network. For the wireless WAN, we can cover long distances, up to 30 miles with wireless technology. Now, whenever, again, we're saying wireless, we're not necessarily saying Wi-Fi. This is typically going to be using long-range wireless technologies like WiMAX or satellite. Now, each of these has their advantages and disadvantages. So, for example, satellite I can get in the most remote places around the world, right? Which is great. I can get coverage of just about anywhere. However, there's latency issues typically with satellite. Since there's a long way to go to get to that satellite, latency is a big deal, and bandwidth can be a big deal, and it can also be very, very costly to utilize satellite services because satellites are costly themselves. So with wireless WAN technologies, we typically lease services from a service provider in this area. Most enterprises don't own their own wireless WAN technologies. They're typically leased from a third-party company.